Close your eyes for a moment and imagine a world drowning in waste, plastic destroying us and the environment. Now open your eyes. Sadly, this isn't something we need to imagine. It's our reality. Hi, my name is Laksh Bohara, and this is how I would solve the plastic issue. Think about the everyday plastic items you use. Credit cards, food packaging, furniture. Many of these plastics are made from plastics like PVC, polystyrene, and PET. Now, they may seem pretty normal, but there's something extremely shocking about these plastics. Well, what is that? All of these plastics are amongst the hardest to recycle. They release toxic chemicals when processed, making recycling unsafe and often unfeasible. Furthermore, here in Japan, a lot of the waste is burned. 60% of plastic waste is burned or dumped in landfills, releasing greenhouse gases, impacting communities near the site. Only 9%, 9% of plastic waste is recycled. So let's take a closer look on what actually happens to that 9%. Some of it turns into nurdles, small pellet-like materials used to create new plastic products. But factories often have to mix in new plastic to create these pellets, which only worsens the issue. Current recycling methods are failing to provide scalable, sustainable, and cost-effective solutions. This made me think, what would happen if we turned our waste into something more valuable? And can a simple act like rethinking how we discard be the key to building a more sustainable future? This means my solution needs to do five things. Number one, it will have to minimize the prevention of greenhouse gases. Number two, it'll have to promote and encourage recycling of plastics. Number three, it'll have to ensure everyone gains some sort of benefit. Number four, we'll have to prevent the addition of new plastic being mixed to create these plastic pellets. And on top of doing all of this, it will have to be scalable, realistic, and effective. This is my solution. My solution is a closed loop plastic recycling and emissions control system composed of two technologies. Now, this may seem complicated, but it can easily be integrated into current systems. My first technology is chemical recycling vending machines, and my second technology is carbon capture enabled plastic incineration plants. This is how it will work. Users like you and me will insert plastic items such as bottles or packaging inside these vending machines, which can be found all across the city. Optical and density sensors will identify the polymer type, for example, if it's a PET or a HDPE. In return, they'll get a small cash incentive. The vending machines will then classify if the plastics can be recycled using AI. If it can, the plastic will then be shredded and processed using chemical depolymerization, which breaks down the plastic into its original monomers. These monomers are purified and repolymerized inside the machine to produce high purity plastic pellets that are chemically equivalent to virgin plastics without adding new fossil based plastics. Then companies can buy this recycled plastic and use it to create new products. Well, what happens to the plastics that can't be recycled? Plastics that cannot be chemically recycled, such as contaminated or mixed materials, are sent to controlled thermal processing facilities. And instead of open burning, which happens all across the globe, these facilities will incorporate my new technology, carbon capture units, to separate carbon dioxide from exhaust gases before release. The thermal energy generated during this process will then be converted into electricity, and this is the same electricity which will be used to power the vending machines. All the energy is reused. The emitted carbon dioxide will also not go to waste. It will be captured, purified, and and fed into closed algae bioreactors who can use it as a reactant for photosynthesis. Together, this system converts plastic waste into reusable material and energy while minimizing greenhouse gas emissions, ensuring all waste is reused and recycled. Now, let me explain why this will work. Firstly, it will solve the quality problem. Now, what do I mean by that? Let me do a demonstration by showing you some math. Let R equal the recycling rate, Q equal the quality of recycled plastic, D equal the demand from manufacturers. Currently, as R increases, Q decreases. And when Q decreases, D decreases. That's one of the main issues with plastic recycling. My system fixes this relationship by keeping Q constant through the automation of vending machines, creating the same quality virgin plastic. Demand stays high even when recycling rate increases. Secondly, it can be easily maintained and requires low cost to install, as it does not use conventional renewable energy such as solar panels, which are extremely expensive to install and are not reliable due to different countries having different weather patterns. Thus, it's a global solution that can be incorporated anywhere and it's energy efficient. It's also scalable and realistic. The vending machines are modular, compatible with existing and can go with existing infrastructure and can be deployed gradually. The system improves recycling rates without requiring lifestyle changes or sudden new behavioral patterns. Fourth, it also aligns with economic incentives. Companies gain access to reliable recycled materials. Governments reduce waste management and emission costs, and communities are rewarded for participation. It's a win win scenario for everybody. No one part of the system depends on this awareness aspect of the issue alone. Because of its material efficient, emissions aware, and economically aligned system, this system can scale sustainably and deliver long term impact. Now, let me tell you the potential for impact. Firstly, by recycling half of global plastic, it could reduce greenhouse gas emissions by 25% and prevent 2.5 thousand kilograms of waste from entering oceans and landfills daily. It also boosts the economy, as a circular economy for plastics can unlock $4.5 trillion by 2040. And recycled materials cost up to 50% less than virgin plastics, creating a win-win scenario for the planet and the economy. It also contributes to community empowerment. Scalable recycling systems could increase local job opportunities significantly, and these reward systems could boost participation. Furthermore, the solution also reduces reliance on low-income countries for waste disposal, creating a more equitable and global independent solution in which LICs can also manage their waste efficiently. Now, I want you to close your eyes once again and imagine communities thriving because of my vision. Thank you for taking your time to listening to this PowerPoint, and I hope I can be part of the Junior Advisory Program.